Any students, here is an example of a linearization and a Taylor polynomial. So the first question is find the linearization of f of x equal to x to the fourth times natural log of x plus 3x minus 5 at x equal to 1. So you can either do it as the equation of the tangent line, where you y minus y1 equals m times x minus x1, or you can kind of remember that the linearization ends up looking like this, right? It's f of a, where a is 1, plus f prime of a, again a is 1, times x minus a. Right, this is really just your y minus y1 equal to m times x minus x1, but solve for y, right? Here's your y, here's your y1, so it's y minus y1 equals your slope m times x minus x1. It's just using different letters. So we have to figure out what f of 1 is and f prime of 1 is. So f of 1 should be straightforward. I'm just going to plug in 1 and get 1 times natural log of 1, which is 0, plus 3 times 1 is 3 minus 5, so I get negative 2. Then I have to find f prime of 1, so let's find the derivative first. F prime of x is, let's see, product rule here, 4x cubed times natural log of x plus x to the fourth times 1 over x plus 3 minus 0. And then plugging in 1, f prime of 1 is going to be 4 times natural log of 1, that's 0, plus 1 times 1 over 1 is, I could simplify this to x cubed. Right, we're not really being asked to simplify this. So it's 1 cubed plus 3, which is 4. Okay, so my linearization of this function at x equal to 1 is f of 1, which is negative 2, plus f prime of 1, which is 4, times x minus 1. And personally, I like to leave it like this, because then usually you get asked some sort of question like, use the linearization to approximate f of, say, like 1.03. And it's much easier to see what happens if you write it like this, as opposed to like, right, you could simplify this and get 4x, and then 4 times negative 1 is negative 4 plus negative 2. You could write this as 4x minus 6, and then you have to plug in 1.03 here. And it's not that bad, but it's just kind of nice to do it like this, because then you can see, oh, plugging in here, this 4 times x minus 1 is only going to contribute a tiny bit. So if I want to evaluate this at 1.03, it's going to be approximately the linearization of 1.03, which is going to be negative 2 plus 4 times 1.03 minus 1, which is negative 2 plus 4 times 0.03, which is 0.12. So negative 2 plus 0.12 is negative 1.88. I'm not going to plug it in, but you can check on the calculator. If you did 1.03 to the fourth times natural log 1.03 plus 3 times 1.03 minus 5, it would probably be pretty close to that. Okay, let's go ahead and look at the Taylor polynomial of this same function. Let's find the second, or maybe even the third degree Taylor polynomial. So for the Taylor polynomials, you need each derivative. So for the second degree, I need at least the second derivative. Maybe actually not always quite that, but you should do that. So I know the original function is here. I know my derivative, actually the derivative is on the other side, so let's go back and look real quick. The derivative is 4x cubed times natural log of x plus x cubed plus 3. Convenient. And then I'm going to need the second derivative as well for the second degree Taylor polynomial. So I'm going to use the product rule again, so it's going to be 12x squared times natural log of x plus 4x cubed times 1 over x. So now, I should write it out. 4x cubed times 1 over x, right? The derivative of this times that, and then this times the derivative of that, plus 3x squared, and the derivative of 3 is 0. Now let's simplify this. 4x cubed times 1 over x is just 4x squared. Which I suppose we can make it even simpler and say, well, 4x squared plus 3x squared is 7x squared. And the reason I'm doing that is because if we were going to go to the next step, you always want to kind of simplify your derivatives at each step. So I see that f prime of 1 is 0, right, because natural log of 1 is 0, plus 1 plus 3 is 4. We already knew that from the previous side. F double prime of 1 is 0 plus 7 times 1 is 7. And let's go ahead and do the third degree Taylor polynomial. So f triple prime of x is going to be the product rule again, 24x plus the derivative, 24x times natural log of x plus 12x squared times 1 over x is going to be a 12x plus the root of 7x squared is 14x, and those go together like 26x. So then f triple prime of 1 is going to be 24 times 1 times natural log 1, which is 0, plus 26. So then I kind of like to write out just the general kind of Taylor polynomial formula. So Taylor polynomial says that f of x is equal to, and here's the kind of the long form, right? It's f of a over 0 factorial times x minus a to the 0th. But we don't really write all that because 0 factorial is 1 and x minus a to the 0th is also 1. So don't really write those. And then it's f prime of a over 1 factorial times x minus a to the first. But again, 1 factorial is 1, so we don't usually write that. So we really just usually write f prime of a times x minus a. By the way, look, here's the linearization formula. It's the same as the first degree Taylor polynomial. And then the next term is f double prime of a over 2 factorial, which is just 2, times x minus a squared. And then the next term is f triple prime of a over 3 factorial, which is 6, times x minus a cubed. And it just keeps going on and on and on. So, writing out our particular function, the first term is f of 1. F of 1 is on the other side, it was negative 2. Sorry, f of 1 is negative 2. So there's the 0th degree Taylor polynomial. And then if I add the next term, f prime of a, or f prime of 1 is 4, times x minus 1. There's our first degree Taylor polynomial, which is the same as the linearization. That is literally the same thing every time. They are exactly the same. And then if I add the next term, it's going to be f double prime of 1, so 7 over 2 factorial, which is 2, times x minus 1 squared. This would be the second degree Taylor polynomial. And if I add the next term, I would get 26 over 3 factorial. I could probably reduce that to 13 over 3 times x minus 1 cubed. And that would be the third degree Taylor polynomial. And if I add on the next term, it would be the fourth degree Taylor polynomial. You definitely don't want to multiply this out, right? You want to leave it in this form. You don't want to multiply out x minus 1 squared over x minus 1 cubed. So there you go.